Hello seniors, in this electronic assignment I'm gonna do the last exercises about this topic, which is higher order derivatives. We have been doing the first set of exercises together during the virtual class, and as it is not a very hard topic, I thought that maybe it would be better for you even if I only do the tutorial video for the last exercises, right? Remember, higher order derivatives is to just keep on finding derivatives of the function, right? If we find the first derivative, we get, well, the first derivative. If we differentiate again the first derivative, we're getting the second derivative. If we differentiate again the second derivative, we get the third derivative, and so on, okay? So that's basically what this is about. So there's actually nothing new, because you know how to differentiate already. We have learned all of the different rules, power rule, exponent rule, derivative of logarithms, product rule, quotient rule, chain rule, and so on. So it's just applying that, but repeating the process multiple times depending on what the exercise is asking for, okay? So we have done this set of exercises, all of this, and here's where we left. Number 3, it says, find the first 4 derivatives of y equals 1 over x, then write a generalization for finding the nth derivative of this function, okay? So, y equals 1 over x. In order to differentiate this, it's better if we rewrite this taking the exponent up. So this is, taking the x up by changing the sign of the exponent. So we're going to get x to the power of -1, right? So this is easy to differentiate because we just need to apply the power rule. So y prime would be -1 times x to the power of -2. And I'm going to just leave it like this because I will need to keep on finding derivatives. So I'm going to leave it as -x to the power of -2. And then we're going to write, well, but just for you to notice, this is the same as saying 1 over x squared, right? -1 over x squared. There you go. Okay, so if we keep on doing the derivative, let's find the second derivative. It's this would be, if we use this would be positive 2 x to the power of -3, right? That's the other derivative. So if we rewrite this, I'm going to write it here just for you able to see this clearly. It's positive 2 over x cubed. That's the second derivative. If we keep on for the third derivative, this would be -6x to the power of -4, right? So if we rewrite it in the fashion way, we're going to get that this is -6 over x to the 4th power. And finally, if we find the fourth derivative, we're going to write it this way. This would be positive 24 x to the power of -5. So if we rewrite this in a fashion way, this is 24 over x to the 5th power. So now we need to find a generalization. So we're going to look at this and see if we can observe a pattern. The first thing I notice is that signs are alternating, right? Negative, then positive, negative, then positive, right? Okay, so that's the first thing I notice. Another thing I notice is these numbers, 1, 2, 3, 6 and 4 and 24, right? 1, 2, 6 and 24. Those numbers, maybe we can write them as, this is 2 times 3. 6 is the same as saying, wait, give me a second. Okay, so we need to think about the generalization, right? We need to do the numbers, right? 1, 2, 6, and 24. One thing I noticed is that, well, this is something that requires a lot of practice and attention in order to be able to realize, right? But one thing I noticed is that, for example, if I work with the concept of factorials, you see that this one over here is 1 factorial, right? 1 factorial is 1. Then 2 factorial. Remember the concept of factorial. Factorial means doing, if I want to find 2 factorial, it's 2 times 1, right? And this is 2. Then for this number, this could be 3 factorial, right? Remember 3 factorial is 3 times 2 times 1, and this is 6. And finally, this number should be 4 factorial. Let's see, this is 4 times 3 times 2 times 1. This is 6 times 4, which is 24, okay? So we would have to generalize those numbers using factorial, right? It's n factorial for the nth term, right? 1 factorial for the first term, 2 factorial for the second term, and so on. Okay, so we already know how to generalize that number on top. Okay. So if I keep on doing this, it's n factorial. So we already have the sign, we already have the number on top, and now we need to work with the number on the bottom, the x in the bottom, right? This is easy, right? Because we see that this is x squared, this is x cubed, x to a fourth, x to a fifth. So we're always increasing the exponent by 1, and we are starting with x squared. So I can say that this is basically x to the power of n plus 1. Remember, n is our position, right? So for the first term, it would be 1 plus 1, which is 2. For the second term, it would be x to the power of 2 plus 1, which is 3. The fourth term would be x to the power of 3 plus 1, which is 4, and so on, okay? So this works. So now that we have all of the terms generalized, we're going to say that the nth term, I'm going to write it like this, yn is equal to work with the negative sign, we see that it's negative in the odd positions, right? 1, 3, 5, and so on. So this would be negative 1 to the power of n. So when n is an odd number, it would be negative 1. When n is an even number, it will be positive 1. So times n factorial to generalize the numerator. And this is all being divided by x to the power of n plus 1. Okay? That would be the general form of this derivative, right? Let me frame this as my answer. So this requires a lot of practice. I don't usually see this type of exercises in real IB exams, but just for you to consider, there's the possibility of having these types of exercises. Okay, finally, for the exercise number 4, it says, find the gradient of the slope of the function f of x equals 3 times the fifth root of x squared. Okay, so there's like we have some tricky words here, right? The gradient of the slope. You should realize that basically what we're being asked with this phrase is to find the second derivative, right? Why is that? Because we know that the slope of the function is referring to, let me underline this, the slope of the function is referring to the first derivative, right? But if we want to find the gradient of that slope again, remember what I told you at the beginning, it's actually right here. It says the derivative is the first derivative, right? And then it says, we are sometimes interested in the gradient of the first derivative, and this is known as the second derivative. So that's exactly what we are being said here. The slope of the function is the first derivative, and the gradient of that slope of the function is the second derivative, right? So if I underline all this, we will now know that this is referring to the second derivative of the function. So basically what I need to do is find the second derivative of f of x. Okay, so I'm going to write f of x equals, and I'm going to rewrite it as 3 times x to the power of 2 over 5, okay? If we write the radical in exponent form, it's that way. The exponent inside the radical is in the numerator, and the index of the radical is in the denominator. Okay, so we find the first derivative of this. The first derivative would be 3 times 2 over 5 times x to the power of 1 minus 2 over 5, that's negative 3 over 5. Okay, so we see if we can simplify something. We cannot simplify, so we're going to multiply 3 times 2, that's 6. 6 over 5 times x to the power of negative 3 over 5. Okay, but now we need to find the second derivative, which is what we're being asked. So we need to differentiate this expression, and this would be 6 over 5 times negative 3 over 5 times x to the power of negative 3 over 5 minus 1, that would be negative 8 over 5. So to the power of negative 8 over 5. And then if I reorganize this, we're going to get the final results. F second of x is equal to negative 18 over 25 times x to the power of negative 8 over 5, which if we rewrite in a more elegant way is 18 over 25 over the fifth root of x to the 8th power. Okay, that would be the final result. Okay. And that's it. That's it for this electronic assignment. I hope this was clear enough. Please, if you have any doubts, let me know. We're gonna cover these doubts in future live sessions. See you.